the second file in the dynamics review that I'm making for 2021. And in this case, we have two cars. Car B is traveling down an incline of 30 degrees, and it is located above car A. And the first part wants us to find the velocity of car B with respect to car A's perspective. So if we look at a coordinate system here, right, so this is our X and our Y, that's attached to car A, what is the velocity of car B going to be relative to that perspective? So the easiest way for us to figure that out is to describe everything in a equivalent plane or an equivalent frame with what we know about the velocities or the speeds of the relative cars, right? So if we say this is our X and Y, let's try to use uppercase X and uppercase Y to not keep those separate from the perspective of A. So if I describe the velocity in A as a vector, we can say that it is going in the positive x direction at 55 miles per hour. And it has no velocity in the y direction, so we're just going to say 0. If we look at the velocity in B, it's going to have x and y components, right? So it's going to have some vby and some, or sorry, that's vbx, and some vby, right? And the proportions of that is going to be a function of the sine and cosine of the angle. So in this case, for our x component, since that's adjacent to the angle, we're going to use cosine. So we have 70 cosine of 30 degrees for our x component. And then we have 70 sine of 30 degrees for our y component. And since that's going down and we draw that as upwards positive, let's go ahead and put a negative on that as well. And those are still all going to be in miles per hour, just as a note. So if we plug those into our calculator, we get our VB equal to 60.6 in the x direction and 35, negative 35 in the y direction. So this means that relative to A, right, or relative to the lab frame, the car B is actually traveling a little bit faster in the x direction and it's going down in the y direction. So the relative velocity, the velocity of B, let's say with respect to A, we want to do the target minus the origin. So in this case, we have the target velocity in the x, 60.6, minus the with respect to velocity, 55. And then again, the target, negative 35, minus the origin, 0, to get the total relative velocity. So my velocity is B, again, with respect to A. And there's lots of ways you could write that to make it a little bit more concise. But 60.6 minus 55, that'll give us 5.6, and negative 35 minus 0, negative 35 miles per hour, right? So VA, if you're looking at VB, is coming down towards it at 35 miles per hour and then out in front of it at 5.6 miles per hour. So this is the answer for our part 1. And then for the part 2, since the velocity in the horizontal direction of the top car is larger than that of the bottom car, we know that it will reach the intersection point first. So we can just say, by inspection, car B, cab, car, let's use uppercase, easier to see, car B will get there first. Or you could probably just say car B. All right. So hopefully, again, that's pretty straightforward. And let me know if you have any questions.